All right, so you should have already seen the video about this stuff where we're evaluating using special right triangles. So sine of 30 degrees is 1/2. Cosine of 30 degrees is square root of 3/2. Down to the 45 degree. This is the special right triangle, and this is a special right triangle. And we use those to evaluate any of those questions. So what if I asked you to find the sine of 120 degrees? Okay, we can still do that without a calculator. So 120 degrees on axes, 120 degrees is, there's 90 degrees plus another 30 degrees is like right about there. Okay, so our angle looks like this. That's our angle. Now, the first thing we have to do, if this is 120 degrees, we have to find out what our reference angle is. Now, our reference angle is the angle it makes with the x-axis. Here's my x-axis. There's my y-axis. Okay, so this is my reference angle. So theta equals our reference angle. So how big is theta? That's our reference angle. Well, straight across, a line gives you 180 degrees. So this reference angle is 60 degrees. So our reference angle is 60 degrees. All right, so I'll ask you just finding the reference angle in your assignment. You'll have to do that. But I asked us how to find the sine of 120 degrees. First, we have to find our reference angle, which is 60 degrees. Now we're going to draw a triangle using our reference angle. So this is my triangle right there. Okay, I'll put it right down here. So here's my triangle. Now, theta here is 60 degrees. This is 60 degrees. Okay, we have a 30, 60, 90 triangle. Okay, so now across from 30 is my short side. I will make that 1. Double it to get the hypotenuse. Multiply the short side times the square root of 3 to get the other side. Now, on these types of problems, you're going to do something that you've been told not to do. Distance can be actually negative. We always say distance is positive, but for evaluating these sorts of things, it's easier to consider it positive and negative. So from this point to get to here, I went left, and going left is negative direction, and then I went up, which is a positive direction. So I'm going to label that -1 and positive square root of 3. Now the hypotenuse is always going to be positive. On all these examples, you'll always have a hypotenuse that is always positive. That's the positive one for sure. This is -1 because we went left, and positive square root of 3 because we went up. So, just like I said twice in our last video, once you have the triangle labeled, it's really just a ratio of two sides. So sine of 120 degrees, using this reference triangle, we can say the sine of this angle right here, theta, is opposite, oh, did I put square root of 2? Sorry, that is 2. I'm not going to redo the video just for that. So that's 2. So the sine of this angle is the square root of 3 over 2. Square root of 3 over 2 is our answer. What if I asked you, what is the cosine of 120 degrees? Well, we already have it drawn. There's my reference angle. Here's my drawing. What's the cosine of this angle right there? It is adjacent over hypotenuse. So -1 over 2, or -1/2. The tangent of 120 degrees would be opposite over adjacent. So opposite over adjacent, square root of 3 over -1, or just the negative square root of 3. All right, so another example. Let's say I want to find the cosine of 225 degrees. 225 degrees. All right, we're going to draw that. There's 90. There's 180. We have 45 left, so right there, that's my angle. 104 or 180 plus 45 gets you 225. So there's my angle. Now, remember, a reference angle is the angle it makes with the x-axis. The angle it makes with the x-axis. So here is my reference angle, right there. Well, how big is it? How big is that angle? Well, 225 minus 180 gives you 45 degrees. That's how big that one is. So we'll draw our triangle. And that's 45. That's our reference angle. Well, if that's 45 and that's 90, this has got to be 45. So we can label them 1, 1, square root of 2. All right, so positive or negative. If I'm going left, it's negative. If I'm going down, it's negative. And the hypotenuse is always positive. So what is the cosine of 225 degrees? Adjacent over hypotenuse. Cosine of 225 equals adjacent over hypotenuse. Or negative square root of 2 over square root of 2. That's our answer. What about the tangent of 225 degrees? Well, that is opposite over adjacent, which is just 1. Okay, I'm going to give you another example. What about, let's find the tangent of 330 degrees. Okay, maybe I'll ask you, what's the reference angle? Reference angle. All right, so we're going to draw 330 degrees. 90, 180, 270. So it's between 270 and 360. 360 is all the way around. 360 is all the way around, so we're 30 degrees short of that. So we'll draw it right there. There's a 330 degree angle. 330 degrees. So we always connect the end of our arrow with the origin there. And there's our angle. Now, what's our reference angle? It's the angle that it makes with the x. It's not this one. It's the angle it makes with the x-axis. This one is the angle it makes with the x-axis. How big is that? Well, the whole thing is 360, so that's a 30-degree reference angle. 30 degrees. Okay, we draw our triangle. We know that this is 30. That means this is 60. This is 1, 2, square root of 3. Okay, so from here, this is kind of our triangle right here. We went right, so that's positive square root of 3. And then down, that's negative 1. And remember, the hypotenuse is always positive. Okay, so now we have it drawn. Tangent of 330 degrees. Tangent, here's our reference angle right there. Tangent would be negative 1 over square root of 3, because it's the opposite over adjacent. So multiply top and bottom by the square root of 3, you get negative square root of 3 over 3. What is the sine of 330 degrees? Well, it's already drawn, so it's opposite over hypotenuse. So it is -1 over 2. Okay, I hope that you understand with these few examples. I wish I was with you in person, but please ask questions, email me, and if you say, I don't quite understand reference angle, or could you go through that again with something else, I'll do more videos, or I'll just reply to your question on the email. So please let me know if it's not making sense. Good luck.